Welcome back to section 3.2. I forgot to write that number down here. We're talking about polynomial functions and their graphs, and we're going to go through some examples on how we graph polynomials. And in this section, we're going to have things kind of set up for us so that they work. And what I mean by that, I'll talk about that when I'm going through some of these. So first of all, what we're going to want to do is when we're graphing a polynomial, now remember what a polynomial is, that means all nice integer exponents, nothing, no fractions of x's and denominators. We can have fractions as coefficients. That doesn't mean, we aren't going to have necessarily nice coefficients, but for these to work, they will be. And what we want to do is we want to find the zeros. And to find the zeros of a polynomial, we're going to factor that. So in this section, these problems will be factorable. And then what we're going to do is we're going to plot those little zeros. That'll divide up our number line into some regions, and we're going to do some test points. So we're going to get some other points on our graph. We're going to talk or think about the end behavior, what kind of happens at the ends. And then we're going to I'm going to include some zero behavior, what kind of happens near those zeros. And then we're going to do a rough graph. Okay, so kind of walking through those pieces. And there's lots of graphing programs out online, so you can always do this and kind of check to see if yours is somewhat close. Ours are going to be very rough. I expect that. But I will be, on the tests and things like that, I will be looking for all of these little details. I'll be asking you for all these little details. So going to a graphing utility and punching it in, yes, that can get you the graph. But knowing how we do this is where we're going to get all the little details. And after all, this is math analysis. We are going to analyze these polynomials to get what the graph looks like. So here's the first example. The nice thing is it is already factored. So we're going to be calculating those zeros. Okay, and when we're looking for the zeros, that's where we have, and we can set each of these little factors equal to 0. So from this factor, and pretty soon you will get to be really good at this. And x plus 2 is equal to 0, so that means x is negative 2. X minus 1, set that equal to 0, so x equals 1. Here we'd have in 0, x is equal to 3. And I want you to be able to get to be that comfortable to pull off the 0, given it in its factored form. You may have to do a little bit of work if we have an uglier looking factor, but you should be able to get to those values. So now what I'm going to do is put those values on my number line. So kind of getting my graph set up here. Okay, we're going to have a 0 at negative 2. So that means we have a nice big fat dot there. We're going to have a dot here, and we're going to have a dot at 3. So right now we have 3 points on our graph. This also divides our curve into, there's a region here, one between these two zeros, one between these two zeros, and then one further down. And I'm going to pick a point in each of those regions, and we're going to plot a point. I'm also going to be looking at some of those other things to verify if I did things correctly. So I'm just going to start as we read from left to right. I'm going to randomly pick any number that's in this region that's below the negative 2. So I'm just going to do negative 3. And I'm going to substitute it in there so I can get another dot or another point on my curve. So substituting in negative 3 there. And these problems just take time and patience, and it's all in the details. So this is negative 1 times negative 4 times negative 6. So that's a negative 24, which is, I don't know, pretty far down here. So I'm going to put a dot way down at the bottom of my paper. Kind of ran out of room. I'm going to pick a value between -2 and 1. I love x equaling 0. So substituting in 0 there, and I'm going to substitute that in and get my values right away. So I'm going to have 2 times -1 times -3, which gives me +6. Put some more lines in here. 1, 2, 3, 4, 5, 6. There we go. Whoops. That would have also been that y-intercept. That would have been a nice one to choose. A number between 1 and 3, maybe 2. Substituting 2 in here gives me 4 times 1 times -1, so I'd get -4. And then a value beyond 3, so possibly 4. So putting 4 in there, I get 6 times 3 times 1, which is 18. So again, they're not quite as far down. It is. Okay, so there are some more points. This is also to help me determine, am I above the x-axis or below the x-axis? So those are my test points. My end behavior. So remembering when we talked about if we have an even degree, they're both going to be going up or both going down. In an odd degree, they split. So one starting in the basement, ending in the ceiling, or starting in the ceiling, ending in the basement. So we have to determine, is this of what degree? So if I multiplied this thing all out, so multiplying those two together would give me a quadratic, because I would FOIL it. And then multiplying that in, that x squared times this x is going to give me an x cubed. So this is going to be a third degree. And if I took all my leading coefficients, multiplied them together, I'd get that leading coefficient. I'd have a single x cubed, or 1x cubed. So my a is positive, which means I'm going to start in the basement and end up in the ceiling. And if you looked at our test points on our ends, we were way down here at -24 and already way up here at a +18. So I know it's going to keep going up, and if I could draw, this would keep going down. So that's kind of the end behavior. The way I talk about the zero behavior, so I know it's got to come up here, and it's got to get to the 0. It's going to come pretty fast. Now, what I mean by zero behavior is, how does it cross through, or does it cross through that 0? So I'm going to look at the factor that it came from. So -2 came from this piece, which is of degree, we only have one factor. So that's like a linear or a multiple of 1. So we only have it there once. We don't have like x plus 2 squared or x plus 2 cubed. Since it's only there once, it's going to go through like a straight line. If it were there twice, it would be similar to a parabola at that point. So it's going to come through here like a straight line, and it's got to come up and hit this. This is going to come down eventually. It looks like it's coming pretty fast. Again, at x equaling 1, that's a single factor, so it's going to come through at a straight line. Single factor, straight line. We've got to connect all these dots. Now, I don't know if this is the lowest spot, if this is the highest spot. It might have actually done something like this and then started coming back down, which probably is more reasonable. This might have been the smallest spot, but I know that it's got to hit those points. So the details, if you wanted more details, we could plot more points. In here, right now, we're just going to be concentrating on the zeros, the end behavior, and kind of getting a few points in between those. So rough graphs. Okay, let's do one more so that this video doesn't get too large. And let's do this one. And I'll call this G. And let's do x cubed minus 2x squared minus 4x plus 8. Okay, and the first thing we're going to need are those zeros. And the only tool we have in our toolbox right now to find zeros is to factor this. It is not a quadratic, so it's a cubic because it's a third degree polynomial. I could talk about our end behavior. Degree 3, leading coefficient 1. It's going to end up in the ceiling here, come from down in the basement, so kind of going in our rough pieces. But I do need to find those zeros. And the way we're going to find them is you should see that there are 4 terms. When you think factoring with 4 terms, some bells and whistles, light bulbs, or something should be going off, and you should be thinking factor by grouping. So I'm going to take an x squared out of these first ones, and I'm left with x minus 2. I can pull a negative 4 out because, again, I need to have that x minus 2 in there. Now you can take that x minus 2 out, and I'm left with x squared minus 4. Now, x squared minus 4 factors, it's 2 terms, so that's one of those special cases. That is your difference of squares, which factors as x plus 2 and x minus 2. I'm going to write this because this one showed up twice as x plus 2 and then x minus 2 squared. So our zeros from here, from this one, x equaling negative 2, from this one, x equaling 2. But notice we have it twice, so we'll see something going on a little different than we had in the past. Okay, here this only divides it into 1, 2, 3 different units. So I'm going to take my test points. I'm going to take x equaling negative 3 down here. I'm going to do my work over here. So I'm going to go into, I don't know where we'll go, maybe into here. And x equaling negative 3 gives me a negative 1 times, that's 9 minus 4, which is 5. So I get a negative 5. 1, 2, 3, 4, 5. So there. Okay. I need a one between negative 2 and 2. I like the number 0. So substituting 0 in there, I get negative 2 times a negative 4, which is 8. So I'll get a dot up there. And I need a value out here, so let's try x equaling 3. Substituting 3 in here, we see that it's 1. Oh, and I did not do this one right. Hopefully you guys saw that. If I substitute negative 3 in there, that's a negative 5 times 5, which is a negative 25. So that's way down the bottom. So I really screwed that up. Sorry. This gives me 5. All right. But again, rough ideas, and we do make mistakes. Even I make mistakes. I could not subtract negative 3 minus 2. For whatever reason, I was thinking the 3, not a negative 3. It happens. All right, so we've got our zeros. We've got those plotted. We've got some test points plotted correctly now, or roughly speaking. We've looked at our end behavior. We're going to talk about the zero behavior. This negative 2 came from a single spot, so it's going to act like a straight line. It's got to go from being negative to being positive. This one is coming from a squared piece, so it's going to behave like a quadratic. It's going to come down, touch, and come back up. If this was a fourth power, it would come down and be a little flatter, kind of like the difference between x to the fourth and x squared. And now we're going to be picking up our pieces. And again, how high up these bumps are and so forth, I don't really know. Okay. We could have some more wiggles in there if we wanted to. I do want to point out here that we had a third degree polynomial. So from before, we've also talked about the number of maxes and mins it will have. A third degree will have at most 2. And we do see 2 here. So I know that I don't have any more bumps. So it's going to be kind of a smooth increasing curve, smoothly decreasing curve. One last problem that you see in these sections is we are going to find a third degree polynomial, oops, gotta learn how to spell, with zeros, -1, 3, and 5. All right, so since these are zeros, I know that they come from factors that look like x plus 1, x minus 3, and x minus 5. And if I wanted to multiply those out, I could get that it would be a third degree with those zeros. Is it the only third degree polynomial with those zeros? The answer to that is no. Because there's another third degree polynomial with those zeros. In fact, I could put any value out front, any constant that I wanted to. I could even put the square root of pi. Now talk about ugly. In front. Or make it even negative. And then divide that by 3. So there we have that really ugly leading coefficient. But it's a number. It's just a really ugly number. But the factors would all be the same. So that's how we could find almost any third degree polynomial with those zeros. If they were to find specifying one other point, all we need is one other point, and that would help us determine what that A had to be. We will be getting more details on how to graph polynomial functions, how to graph other functions as we move on. But in this section, we're just getting introduced, just getting our feet wet. So again, our graphs are going to be very, very rough. See you in the next video.